All right, we're deciding whether or not these are monomials or not. Remember, a monomial is a number, a variable, or the product of a number and any number of variables. So anyway, here we go. Here is the answers. Number 1, is that a monomial? No. If you see a plus sign or a minus, sorry, not a minus sign, because it could be a negative, right? Like a negative 3x, is that a monomial? Yes, so it's not that you see the negative. If you see it actually acting as a plus sign or a minus sign, then that's not a monomial, okay? So number 1 is no because of that plus sign. It's negative x plus 5, no good, not a monomial. Number 2, is that a monomial? You have to tell me why. If you're going to say yes, you've got to tell me why. So here's the deal. How else could I write that and have it look a lot like that? First of all, is number 3 a monomial? Yes, number 3 is. We talked about that. So how could I make number 2 look like number 3 and have it still be the exact same thing? Thank you. It would be this. It would simply be 1/2 xyz squared. Isn't that the same thing as this? Right? Being divided by a whole number, being divided by a number, you can just multiply, pull that out and multiply it by 1 over that. Agreed? That's how you get there. So then this is a monomial because it's divided by a number, which means that I could pull it out and put it right here. Make sense? Okay. Number 4, is number 4 a monomial? Here's the rule. I didn't tell you this before. It is not, because what's generally the rule about this? There's a variable as a denominator. That changes things. And so this is not a monomial because there's a variable as the denominator. I believe on the test I put these down here too, where you have to know the difference between a monomial and whether they're a monomial or not. So not a monomial because of that variable down here. Okay, makes sense? All right. Let's look at this now. Let's multiply them. What if I have this 6x squared times 2x to the 8th. We've done this, I believe, already this year a little bit. Right? I mean, so this is... What do I do with this? I need to multiply them. Can I multiply these two things? You can multiply anything. You can multiply anything. You can't always add and subtract them, right? In order to add or subtract things, they have to have a common term, right? They have to have the same term. When you multiply, you do whatever you want, right? 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 Take the numbers, 6 and 2, multiply them together. Isn't this just a string of 6 times x times 2 times, right? I mean, isn't it just that big string? Okay, so then I can move things around. Can't I go 6 times 2? 12. They're gone. And then go, okay, I have x times x times x times x. So how many x's are there? 10. There's 10, so it would be x to the 10th, right? 6x squared times 2x to the 8th is 12x to the 10th. Make sense? Okay. You guys try one then. Let's do a good one here. We'll do a big ugly one. 3px to the 3rd times p to the 3rd x to the 4th. You guys got it? So here it is. First of all, look for the numerals. Is there numerals to be multiplied here? No, there's just a 3. So we'll change colors again. So the 3 is just down here. He's gone. And now you look and go, okay, I have p times p times p times p. So p times p to the 3rd is p to the 4th. Right? Gone, gone. And then how many x's do I have? Right? Okay. Try another one. One last one, then we'll move on to something else. Numerals. I have a -4 and a -6. When I multiply them together, I get 24. Okay. I have an r, and then I'm going to multiply it by r to the 5th, which is r to the 6th. I have x squared times x squared, which is x to the 4th. T to the 3rd times t is t to the 4th. I'm done. How many of you got that? Yes. Here's the deal. If they write it like this, then I'd leave it like this. But as a general rule, you should put the t before the x, right? I agree. But if they give you this question like this, then somehow the xt is supposed to be like that. I don't know. I wouldn't mark it wrong either way. Make sense? Okay. How many of you got that one again? Raise your hand if you got that right. Are you understanding yet? Okay. What about this? An ugly one. Okay, here's a good one. Whoa, hold on. I got to do this right. Okay, you don't need to give me the real answer. You can leave the 2 as the base. But I remember we did this a little bit already. Haven't we did it this year? Or was that pre-algebra? I don't know. Okay. Here's the deal. I'm going to show you this one. Ready? That 4, when you do exponents, you got to start with the outside one, right? You're technically supposed to start with the one that's in the middle, right? You go, okay, 2 to the 3rd squared is, if there's 2 sets of 2 to the 3rd, right? Here's 2 to the 3rd. Doesn't that 2 here mean that there's 2 sets of what's in there? Okay, so then that would mean that there is 2 to the 3rd times 2 to the 3rd. Agreed? Okay, so what's 2 to the 3rd times 2 to the 3rd? 2 to the 6th, right? So we have 2 to the 6th now. And then we have 4 sets of 2 to the 6th. 4 sets of that would be what? 2 to the 24th, right? Whenever you have exponents of exponents, what do you do with them? Did you notice what we did before when we had the ones like this? If I have x squared times x to the 3rd, what do we do with these guys? You add them together. When we have exponents of exponents, meaning like they're all strung together like this, it's squared of a 3rd of the 4th, right? I mean like this, then what do you do with them? You multiply them. Because there's sets of each one. So it would look like this. It's 4 sets of 2 sets of 3 of 2 to the 3rd, right? So you can even go, there's 2 sets of 2 to the 3rd, and there's 4 sets of that. So you're just multiplying them. Exponents of exponents, you multiply them. It's that simple. So all you needed to do here with this is go 3 times 2 is 6, times 4 is 24, 2 to the 24th, and you're done. What if I gave you this? 3 to the 5th, to the 3rd, to the 4th. What's the only thing I need to do? Multiply 5 by 3 by 4, right? 5 times 3 is 15. 15 times 4 is 60. 3 to the 60th. I'm done. Right? No different than if I give you one that looks like this. In this situation, I mean, you could rewrite this like this. You could go -2 to the 3rd, x to the 9th, y to the 3rd. I want you to see what I did there. Right? Now, when you write -2 to the 3rd, that is -8, right? So you -8, x to the 9th, y to the 3rd. Does that make sense? 3 sets of those things. I just multiplied those 2 to get the 9. And then I technically multiplied the one that's right here. What belongs above the y? Oh, there's a 1. It's just invisible, right? It's just invisible. Still y to the 3rd. Agreed? Okay, you guys. Let me see here. Okay, here's a big ugly one. Okay. Ugliest one. Oh, man. Good luck. Oh, I love it. All right, here we go. Just you're watching now. You realize this is all one big monomial, right? This is one giant monomial. It's one big set of multiplication here. Let's do the exponents where we can, right? So here's the deal. Here we're going to do this first set of exponents, or we're going to take care of that guy right here, right? What is this? 3 squared? What is 3 squared? What is 3 squared? 9. X squared is x squared. What is y to the 4th squared? What is the rule? Exponent of an exponent. What do I do? It's 2 sets of 4. Right? Isn't it? Look, it's an exponent. It's 2 sets of everything in here. Agreed? It's 2 sets of everything in there. That's why it's 3 times 3 is 9. X times x is, and then y to the 4th times y to the 4th is y to the 8th. Right? Remember? Now we go over here and do this one. I have 2 sets of what's in here. Okay, well that would be negative 2 times negative 2. We'll just leave it at negative 2 for now. We'll go negative 2 squared, y squared, and that is all to the 3rd. Agreed? Do you see that? Okay, and then we go, okay, now we have to fix that. So we're going to get rid of this. We're going to go, okay, 9x squared, y to the 8th, and then now we're going to do this thing. Negative 2 squared to the 3rd. What do I do with those? You multiply them, so it goes negative 2 to the 6th. And then y squared to the 3rd is y to the 6th. Can I combine this stuff now? It's all one big string of multiplication. What is 9 times negative 2? Negative 18. They're gone. Sorry, that's not true, right? That is not true. Yep. We have to do that. What is negative 2 to the 6th? Oh, boy. So it would be, is that 64? 2 times 2 is 4, 8, 16, 20, 16, 32, 64. So it is negative 64, positive 64. 64 times 9. What is it? 576. Now we got rid of our numbers. And then x squared and y to the 14th. Makes sense? You won't have to do very many of those, but you have to know how to do them. Like I said, if you can't do this, then you're in trouble, right? If you can't do this thing up here, you're in trouble. Okay. Really quick, how do I find the area of a triangle? If this was 8 and this was 6, how do I find the area of a triangle? What's the rule? What is it? Nope.
Isn't it base times height?
Base times height. Half, right? It's half. It's 1/2 base times height. A parallelogram, if it looked like this, right, then it would just be base times height. But it's a triangle. All triangles are exactly half of a parallelogram. That's why it's 1/2 base times height. 1/2 base times height. I would write that down if I were you, because you have a question that will require you to know 1/2 base times height. Number 40. They ask you to give the area of that triangle. Yeah?
Can you tell us the rules of including the negative if there's an exponent behind the number, for example?
There's no rule. You just do it. Oh, you mean like, so if it was like this, negative 3x squared, and then you have a 3 out here. You want to know the rule as in like, what do I do with that? This is no different than negative 3 to the 3rd. So the negative is being exponentiated. The negative is included. It's not like it's out here. It's not negative. This and this are different. Make sense? That negative's on the outside. So when you have a negative in there, you're exponentiating the negative number. Okay? All right. Let's see how much I give you here. Because this could get ugly. You see how ugly this could get? I'm going to give you number 54. I can't wait to do it. And 56. I'm giving you 56. I can't wait. I can't wait to do it. What do I say? Oh, I have 21 to 54 even. Yeah, we're going to change that. We're going to go page 405, 21 through 56 even. Yeah, buddy. I'll put an asterisk by number 56 so that you can remember to thank me for doing that.
Thank you.
Yes, you're welcome. If anybody gets 56, I'll be impressed. It's just long. You all know how to do it. No, you can get a good job. I mean, like it's not like this is hard. It's just long. Be meticulous, and you can do it. That is really huge. So what?